Can I sit?
Hey guys, I started going and then I forgot to record. So I'm going to run through this really quick and we'll catch you up to speed, all right? So from horizontal, from this spot right here, if you are going down, if your angle is going down, it's an angle of depression is what it's called. From horizontal, if you elevate that or go up with the angle, that's an angle of elevation, okay? So from horizontal down, this guy right here, horizontal up is an angle of elevation, all right? Example 1 says an angle of elevation of 38 degrees is this girl standing here. She's standing here and she's looking up at a castle, and it's an angle of elevation of 38 degrees, okay? Here's the bottom side. They say the castle, she knows from the brochure that the castle is 190 feet tall and she is 5.5 feet tall. So I went ahead and drew this over here, and she wants to know how far is she from the castle to the nearest foot. So we're trying to solve for this bottom side. Okay, ready?
All right.
What is this side right here?
190.
It's not 190.
18 feet.
Because 190 incorporates from here to the ground level, right?
So 190.
And she is 5.5. So keep that in mind. She is 5.5. So 184.5. That's how tall it is from just here to here. Okay, does that make sense? Do you guys see that?
Yeah, because
You have to kind of put 2 and 2 together because the whole thing is 190.
Well, but her eyes are probably like only 5.3 feet. So
I think they've taken that into consideration.
Okay.
Oh no, if Leah's 5.5 feet tall, right? So it's probably only 5.3.
Yeah.
But we're just gonna go with 5.5.
Sounds
Okay,
good.
because we don't know if she has a tall forehead or a short forehead, right?
Every time I have forehead, I just think crazy.
Okay. All right, so let me get rid of all this junk in here, and let's.
No, I know. Mine's smaller than yours.
So we have this going on here, 184.5, and we're trying to solve for this guy. Okay. Now it's set up the same way as we've been doing. We use either sine, cosine, or tangent. So 38 degrees. Let's look at what we have and what we need. 184.5 is the opposite. The question mark that we're trying to solve for, we'll call him x, is the adjacent. Which trig function is opposite adjacent?
Opposite adjacent is tan.
Tangent, TOA. Tangent of what?
38.
38 degrees equals?
0.7812.
Hold on. Tangent of 38 degrees equals what over what? Tangent is TOA.
So it's opposite.
So
over...
opposite, so 184.5 goes on the top, and the adjacent goes on the bottom.
Well, that's annoying.
Okay? That is annoying. I know.
So,
I know.
Because you got to take the negative one thing now, right?
No.
Wait,
no.
184.5.
What one is the negative
So
one?
now you switch those. When do you do the negative?
Oh, whenever it's tangent of x.
Yeah, whenever you are solving for something in here, that's when you do the negative, okay? But we're not doing that. So you just switch these two around. So x is equal to 184.5 divided by tangent of 38. Yeah?
0.085. What?
Are you in radians? Hit mode. Hit the mode button.
How did you?
Yeah, I got 236.
236.15. Oh, but they went to the nearest foot? To the nearest foot. 236 feet. Okay? That's how far she is away from the castle, yeah? Good? Makes sense? Okay, now this one's an angle of depression. And it says a search and rescue. Do you know how to switch it? Kira?
No, I'll figure it out.
Okay, I can switch it for you too here in a second. A search and rescue team is airlifting people from the scene of a boating accident when they observe another person in need of help. If the angle of depression to the other person is 42 degrees and a helicopter is 18 feet above the water, what is the horizontal distance from the rescuer? So we are trying to solve for x, this bottom right here, okay? And the helicopter is 18 feet, so I'm going to put 18 here. Now, angles of elevation and angles of depression, you have to be very careful because 42 degrees, this is the triangle that's made, yeah? 42 degrees is here. That's my angle of depression.
And there.
Okay? Yeah, hold on. 42 degrees is the angle of depression right there, right? Okay? So this one would be 48, which means this one has to be 42, right? Okay? So angle of depression, if this is your angle of depression, your angle of elevation will technically be the same, right? Okay? Another way of looking at that is if these two are parallel lines to each other.
Is that how it
That's a
always is?
transversal. That's always how it is.
Okay.
Because this and this will be alternate interior angles. Yeah? That makes sense?
Yes.
Okay, so Or you could just map out, this guy is 42, this guy's 48, this is 90, so this has to be 42 as well, right? Okay, so we have x, or we have 18, we're solving for x. Would you like to use 48 degrees or 42 degrees? It does not matter, but it will
42.
change what trig function you use.
42.
42? Sure. So, 42 degrees is here. What is 18 in relationship to that?
Opposite.
Opposite
Adjacent.
and adjacent.
So tangent.
So, we're going to use tangent
Not
again.
again.
Not again. Tangent of what? 42 equals opposite over adjacent. So 18 over x. And what do we do with the x's in the bottom?
Switch.
We
Divide.
switch the two. So x is 18 divided by tangent 42. Somebody do that real quick.
Okay.
What? 19.9?
Someone check.
It's 19.9, but it rounds up to
It's round up to
19.99.
20.
It would round up to 20.0.
Yeah.
20.0. I always like to put, if you round it like that,
Put the
seriously
line
put
over it.
put the 20.0 on the end of it, because a lot of people think 20.0 is the same thing as 20. Right? We've talked about that before, because 20.0
is a more
means that
exact
this
measurement.
number could not have been 20.2, right? Versus this number could have been 20.2. Yeah? Does that make sense?
Yeah.
Right? So by putting the 0.0 on the end there, it tells me that you are really being accurate with your answer. Yeah? So go ahead and put the 0 on the end if you ever round it like that. Okay? Because that tells me that you are being very, very accurate. Okay? So 20 feet. This other person is 20 feet away from where they need to be pulled up from. Okay? From the bottom of the helicopter. Okay? Good? All right. Now, let's see. This, we're going to get a little bit harder stuff.
No.
Okay? To estimate the height of a tree that she wants to remove, what do they have the height of the tree labeled as?
I can't read it.
X, right here. Height of the tree is labeled as X. Mrs. Long sights the tree's top at an angle of elevation of 70 degrees. So we have this triangle right here that's 70 degrees. Okay, here's what I'm going to do. I want you to do this as well. Make a triangle that's 70 degrees. X is here. And we don't know how far she was away from the tree, but there's that. So we're going to call that X, and we're going to call that Y, yeah? Okay, so do that. That's that purple triangle in there. Okay, I'm going to switch colors. And what she's going to do is she's going to step back. So she's standing here in this corner right here without arms. Now she has arms. She's standing there, and she steps back 10 meters. So now she's standing here. Okay? She's stepping back 10 meters, and now she is there. And now her angle of elevation is only 26 degrees, right? It was 70 degrees to start with because she's looking almost straight up at the tree, right? Then as she steps back, the angle is going to be a smaller angle. Does that make sense? As she steps back. Okay? So as she steps back, I'm going to draw a new triangle. Still, the height of the tree has not changed, so it's still going to be X, right? But what's this bottom side here going to be? What'd you say?
10 plus
Yes, 10 plus Y, exactly. 10 plus Y. Okay, it's not 10Y, it's 10 plus Y. Angle of elevation is 26 degrees, like that. Okay. Now, one other thing that we have to take into consideration, star, she is 1.7 meters tall. Okay, we're going to take that into consideration later. Okay, because if you look at this X right here that we're solving for, is that ground level?
No.
Right? We've got to add that 1.7 onto the end there.
That's
Does that make
her
sense?
level.
Okay, that's her eye level, or her however tall she is from her up to the tree. Okay, so this one's a little bit harder. Pay attention to this one. Ready? Okay.
Wait,
All right.
can you go over a little bit?
We have two like that. She is 1.7 meters tall. Okay, this is kind of a tough one. Ready? Pay attention to this. Here is my 70 degrees. X is what?
Opposite.
Opposite. Y is the adjacent. Okay, X is the opposite, Y is the adjacent. So, tangent of 70 equals opposite over adjacent,
X over Y.
X over Y, right? Okay, now, this is hard because we can't solve for X and Y at the same time, right? We never have two variables at the same time. Okay, so let's jump over to this guy over here. Let's jump over to the second triangle. And let's do the same thing there, okay? So we have 26 degrees. What's X? Opposite, what's the other one?
Adjacent.
Adjacent, okay?
Tangent.
So we have tangent again, and this is tangent of
26.
26 equals
X over 10 plus y.
x over 10 plus y, right? Okay? So now we have two equations that both involve x's and y's at the same time, right? Okay? So here's what I'm going to do. Both of them involve an x, okay? So here is x and here is x. All right? What I'm going to do is I'm going to take the y and I'm going to multiply him to the other side. So x is equal to y times tangent of 70, yeah? Does that make sense? X is equal to y times tangent of 70. You see how that works? I'm going to do the same thing to the other side. Times 10 plus y times 10 plus y. Eee. So x over here is equal to, what does this make?
10 plus y.
10 plus y times tangent of 26. Right? Okay? So we're just doing the same thing. We're just multiplying the bottoms over to the other side like we would normally, right? Except we can't solve it because there's a y involved. Right? So x is equal to this, but x is also equal to this.
So equal. 7 equal.
So set those equal to each other, right? This guy will be equal to this guy. Do you see that? Okay? So y times tangent of 70 is equal to 10 plus y times tangent of 26. Okay? This looks really ugly, but we're going to fix it here in just a second. Okay? So you set those equal to each other, yeah? All right? Now, somebody in your calculator, figure out what tangent of 70 is and what tangent of 26 is.
Tangent of 70 is 2.75.
So we have y times 2.75, okay, equals 10 plus y times
0.4.
0.49,
Yeah.
okay? All right, and now it's just an algebra problem. You see it? We have gotten rid of the tangents. We've evaluated those, okay? Y times 2.75, I'm going to write that as 2.75y, right? Equals, okay? Now this guy, 0.49, I have to distribute him. Okay, what's 10 times 0.49?
4.9.
4.9, you just move the decimal, right? And plus 0.49y. Okay, do you see the three pieces that we have up here? 1, 2, 3.
Subtract.
That one.
Subtract
And then
0.49y.
2.26.
0.49y. Okay, 4.9 goes here. 2.75y minus 0.49y is like
2.26.
2.26.
And now divide.
And oh, I forgot my y. And divide by 2.26.
2.17.
Y equals 2.17.
Yay.
Yeah?
But now we gotta solve for x.
Mm.
But now we can because it's like easy now. Kinda.
Okay, we didn't even want y to start with. She was right here. This is what y was. I'm gonna get rid of this stuff. We don't even want y. She was 2.17 meters away from the tree when she looked up and saw the 70-degree angle of elevation. This is 2.17. Okay, but I want x. So check out over here. We have these two equations. Which one's easier?
The left.
The left one, right? Okay. So let's plug y 2.17 in here. What's 2.17 times tangent of 70?
5.
5.9.
Maybe.
So
Right.
6.0.
5.96, 6.0.
Mm-hmm.
Okay. 6.0. And that's in meters, right? Okay. So we plugged that y back in, 2.17. Solve for x is 6.0 meters. Okay. But that tells me 6.0 is here. Is that how tall a tree is?
No.
No, how tall is the tree?
You have to add 1.
We have to add the 1.7. That's where the star is, 1.7. So the tree equals, finally, 7.7 meters tall.
You know, they could have just got a big old tape measure and measured it.
Right. But I'm a shorty, so I can't. I could pretend all day long that I'm going to reach the top of the tree, and I'm not. And I'm too clumsy to get on a ladder, so.
I guess so.
Get an X.
Okay.
I would fall trying to get onto the ladder.
Excavator.
Yeah.
All right.
Get an X.
I don't think I give you too many of these on your homework assignment, like maybe one, if that. because these ones are kind of tough. Oh, was that it?
Yeah.
That was it. But the beautiful thing is you can solve for things like by doing sine, cosine, and tangent even when they're messy, right?
Is it supposed to snow over the next 2 days?
I don't know. I don't know.
I'm gonna run away. It says
'Kay.
more rain, some snow over the next 2 days. See
I
how
don't know.
much.
I'm
It's
gonna
not,
give you
it's
It's
not
supposed to
supposed to
rain.
snow till Wednesday now. Till Wednesday.
Oh, run me over with a car when it does, because I don't
It's
want
supposed to,
that.
yeah, it's supposed to rain like all week. All right, so I'm gonna give you this paper and then I'm gonna show you what they mean by like number 1, 2, 3, and 4. Cause these ones
It
are-
was snowing yesterday while it was
It was
raining.
Flurry.
It rained so much that we had a baby calf drown.
Aw, that's kind of
It-
sad.
it died.
Did you say
Yeah.
cat or calf?
Calf.
Oh, a calf, not a cat.
Oh, a calf.
That's a lot more sad than a cat. I was like, wow.
All right. Take a look at number 1. Name the angle of depression. Which one's the angle of depression?
L.
L, but let's name them with 3 letters.
FLS.
So depression, angle FLS. Yep, that will work. What if you called it SLF? Would that work? Yeah. Elevation. What's the angle of elevation?
TSL.
TSL. Sure. That's what they mean. That's what they want. Depression, elevation. Yeah. You're doing that for each one of those 3. Okay. This one's my depression. This one's my elevation. Yeah. Good. Good. Okay. So keep doing those, and then you have 2 problems on this side, and then like I don't know, 6 problems on the other side or something like that.
God, you're
right. So
No,
far.
actually,
Okay.
fine, I'll be honest.
Not too bad. All right, everybody say bye, Kelsey and Casey.
Bye, Kelsey and Casey.